byte, and this is 10 bytes, and this is 50 byte. So this is 60, 75, 77. So this is taking 77 bytes. So this is another example. This is just for a student. You can define it for an employee. So you can have employee ID, employee name, employee's department, employee address, employee phone number, so on. Then if you want to define a structure for a book, you can give book title, book author name, book version or edition, then year of publication. So you can have all the members. So a lot of data you can combine together under one name. And when you declare a variable of type student, suppose for example, for this, if I do further, then this is a variable I'm declaring, struct student S. So I can say S dot roll number, I can set the roll number. Let us say roll number is 10. Then I can say S dot name, and I can assign some name. Like this, I can access all the members. This is just for one student. So similarly, we can have for various students, and we can deal with their information in our program. So next, one more example for a structure I will take and show you. So next example, I'll take an example for playing cards. A playing card will have some properties. It will have a face value. Let us say kings of hearts. So this is a face value, and this will have color, that is red color, and also shape is hearts. Any playing card can be defined in terms of three properties. First is face value. Then face value can start from 1 onwards. 1 means, let us call it as ace. 1 is ace. Then 2, 3, 4, 5 up to 10. Then a J is 11, and queen is 12, and king is 13. So these are the face values from 1 to 13. The next is shapes are there. So what are the shapes? There are 4 shapes like hearts, diamonds, spade, and clover or club. So 4 shapes are there. So let us define those shapes in terms of codes. We'll give codes for them. Let us say 0 is for club. So this club will be like this, right? And 1 is for spade. So this is spade, all right? Then 3 is for diamond. Let us take it as diamond. And 4 is for hearts. So let us define these as shapes. So for each shape, I have given a number. Then now next thing is color. So as there are only 2 colors, so I will define colors also in terms of codes. Let us say 0 for black color and 1 for red color, right? So 1 for red color. So black and red color. So this is how we can define a playing card. Now this I can represent it as a structure. Let us define a structure. Struct card. What are the members? All these are integers only now. This is integer, right? So all are integer. First one is integer face value. And the second one is integer, that is shape. And the third one is integer, that is color. This is how we can define a playing card. So this is the definition. Now how much space is it taking? Suppose if I say integer is taking 2 bytes, so total 6 bytes of memory it is taking. This is just a definition of a card. Now let us declare the variable. So inside the main function, if I declare a variable of this type structure, so I can have a playing card, struct card, and just C. Now this C, how it will occupy the memory? It will have 3 members. First one is face, and the second one is shape, right? And the third one is color. Now I can access all these members by using dot operator. I can say C dot face assign ace. So for that I will write 1. C dot shape, the shape is suppose 0. So this is for club or clover. Now C dot color, this is black color definitely. So this is 0. So this is how I can create a variable of type structure, and I can initialize its member. So this will be 1, 0, 0. So you can see that I am using dot operator. Now otherwise, let us forget this. Otherwise, I can directly initialize also. Struct card C, I can directly initialize the value. That is, the first face value is 1, and the shape is 0, and the color is also 0. So this is declaration plus initialization. And inside the memory, it will be here, like C will have 3 members, 1, 0, 0. It will be inside the stack that belonging to the main function, or the stack frame belonging to the main function. Now one more thing, I'll just remove this and show you one more thing. See, inside the main function, I want to have deck of cards. So total there will be 52 cards. This is the definition of a card, so just for one card. Now likewise, I want 52 cards. So I can declare a variable struct card. Now this is the structure name. Now variable name, I will call it as a deck of size 52. This will form an array of structures. This is important, array of structure. So I'll be having 52 such structures. So one structure is taking 6 bytes. Total how many bytes it will taking? It will be taking 52 into 6 bytes, right? So 312 bytes it will take. So I'll get 52 different cards. Now each card I can access it with the help of its index. Even if I can initialize this array of structures. So if I want to initialize it, for few cards I will do. First card is ace of club or clover and black color. This is first card. Then second, that is card 2, face value is 2, and this is club and color is 0. So on, I can fill this one. Now afterwards, if suppose I want to start filling the other colors, other shapes, like ace of, that is next is spade and the color is 0, right? Then card value is 2 and it is a spade, so next is color is 0. So this is face value and this is shape and this is color. So like this, I can fill up all 52 cards if I want to initialize them. So we can initialize an array of structures like this. This is the first structure, then second structure, then so on. So in this way, we can initialize array of structures. If I want to access them individually, like the first card I want to display, then I can use dot operator. So let us print just a face value of first card. Printf %d deck of 0, that is this card, dot face. So it will show face of this first card. Then printf next %d and deck of 0 dot this shape. So I can display shape. That's it. I can display other things also, like colors also I can display. So this is how, by using array name, then the index, then I can access it. So here we have learned how to define a structure, how to declare an array of structure, and how to initialize. If you want to initialize, then how to access the members. So this I'll be giving a demonstration also. This is sufficient right now for the structure. More about the structure, that is pointed to a structure, and the parameter as a structure, we'll be learning them in coming videos.